Hello, Warhawks. This is Mr. Tipton. We're doing today Chapter 6.4, Right Triangle Similarity. We're going to give you some rules for right triangle similarity. Hopefully make this as painless as possible. The first thing we're going to need to know what the definition of it is a thing called the geometric mean. To find the geometric mean of two numbers, you put them in a proportion with x, where they are being multiplied as follows. So if you say, what's the geometric mean of two numbers? This is the proportion you should set up. And it really doesn't matter if I put 9 there, or 4 there, or 4 there, and 9 there. Or I could even put x up here and x down here. I could switch it up. But the important thing is that you're multiplying the two numbers times each other when you cross multiply. And you're multiplying the x's times each other when you cross multiply. That's going to give us the geometric mean. So let's see what happens here. X times x is not 2x. Be careful with that. It's actually x squared. And then 9 times 4 is 36. Then, to solve for x, we want to get rid of this square. The opposite of squaring is to square root. So we get that x actually equals 6. So 6 is the geometric mean of 9 and 4. Moving down, we're going to try to find the geometric mean of 5 and 12. Sorry about that. We're going to find the geometric mean of 5 and 12. Now again, I could set it up like this, or I could set it up differently. The important thing is, though, that we're multiplying the x's times each other here. So when I cross multiply, I do x times x, that equals x squared. And then I do 5 times 12, which equals 60. I then take the square root of 60. Let's see what that ends up being. It should be 7.7 is the geometric mean, rounded really, but the geometric mean of 5 and 12. Now, like I said, it wouldn't really matter. I could set it up where x over 12 equals 5 over x. It really doesn't matter, just as long as I'm cross-multiplying those x's and cross-multiplying the two numbers that I'm trying to find the geometric mean for. And that's it. But you have to know what geometric mean is, and that is what it is. We move on. So using the geometric mean in right triangles, we have an altitude similarity theorem. I'm going to call this the altitude rule. So here we have a triangle. An altitude has been drawn, and it has to be a right triangle, by the way. These are all right triangles. An altitude's been drawn in the right triangle, and we want to find out what x is. Well, there's a shortcut we can use. These are actually similar triangles, but if we just use the altitude rule, it becomes very simple. So let's read this. The altitude is the geometric mean of the two parts of the triangle's hypotenuse. So this is a part, that's a part. So x, the altitude, is the geometric mean of 4 and 11. So let's find the geometric mean of 4 and 11. Well, I do 4 over x. Remember, I want an x there, and I want to multiply the x's, so I put x over 11. Now we're finding the geometric mean of 4 and 11. I cross multiply. 4 times 11 is 44. X times x is x squared. And then I take the square root of 44, which ends up being 6.6. So x there is going to be 6.6. It is the geometric mean of the two parts. Let's move down a little bit. Okay, this time I've given you the altitude, but again, the rule stays true. This is a little different though, so pay attention closely. The altitude is the geometric mean, so this is going to change. That is our geometric mean. So in these equations, it's going to take the place of x of the two parts. So I'm trying to find what x is, but remember 5 is now my geometric mean. So instead of doing x times x, I'm really going to do the geometric mean, which is 5 times 5 over x, and then 12 down here at the bottom. So look at the change there. 5 is the altitude. The altitude is the geometric mean. I've already solved for that. It's been given to me. But when I set it up, remember, I want to multiply the geometric mean times itself. So I do x times 12 is 12x equals 5 times 5, which is 25. And then I just divide 25 by 12, and I get 2.1 for x. So that's a little bit different. That's tricky, but that ends up being my answer. Now let's look at the last part here. I call this the leg rule. So with the leg rule, it's a little bit different. The leg is the geometric mean of the whole hypotenuse and part of the hypotenuse closest to the leg. So here we have the whole hypotenuse. Here's our two legs. This part would be closer to this leg, and this part would be closer to this leg. So let's see how this looks. So again, the leg is the geometric mean of the whole hypotenuse. So I need to find that whole thing there, which is 12. And then I'm going to choose the part that's closest to the leg I'm trying to find, which is actually 3. So let's see how this looks. Remember, x is the geometric mean of the whole hypotenuse. So I want the x's multiplied by each other. The leg's the geometric mean. We're multiplying that by each other. Is the geometric mean of the whole hypotenuse and the part that's closest to it. So 3. Let's cross multiply. X times x is x squared. 12 times 3 is 36. I take the square root of 36, and x ends up being 6. Moving on a little bit. Okay, same triangle, except this time I'm trying to find y. So again, the leg is the geometric mean of the whole hypotenuse, which we found was 12, and the part of the hypotenuse that is closest to this leg, 9, is the closest one to this leg. It actually touches it. So again, the whole hypotenuse, y, is the geometric mean of the whole hypotenuse and the leg, or the part of it that's closest to that leg. So we cross multiply. Y times y is y squared. 12 times 9 is 108. And we take the square root of 108, and we get 10.4 for y. And there you have it. All right, I hope you enjoyed it, and we'll see you in class.